to look at the concepts of inverse trigonometric functions, and then we're going to do an example using the inverse trigonometric functions. So we've been working primarily with three different types of functions. We've been working with sine, cosine, and tangent. And when we look at the inverse, your calculator, your TI calculator will have a key for the inverse. It's usually second and then the sine, or second, then cosine, or second tangent. But to denote that we are using the inverse, we're going to use this -1. So sine to the -1, cosine to the -1, tan to the -1. It's not really a power, it's more just saying we're working with the inverse. Because if it's sine to the -1 power, that's something totally different. That is actually cosecant. So this is the inverse sine, this is the inverse cosine, and this is the inverse tangent. The domain for this, so the domain for the sine is going to be between -1 and 1. For the cosine, the same, -1 and 1. This is going to be a bracket because we do not include that, because again we saw previously that you do have to have a defined domain for a one-to-one function. And then for tangent is always increasing, so the inverse is always going from left to right. My range for each one of these is going to be -pi/2, because remember in the last one we have to have a one-to-one function, so we're looking at the valley to the peak, and for sine it's between -pi/2 and pi/2. For cosine, we're going to go from the peak to the valley, so from the maximum to the minimum, and for that, that's from 0 to pi. And again, with tangent, we do have those vertical asymptotes that happen at -pi/2 and pi/2, so that becomes our range, because you're reversing your x's and your y's, you're reversing your domain and your ranges. All right, graphically, this looks something like that. Graphically, the inverse of cosine looks something like that. Let me see if I could do that a little bit better. There we go. And the inverse tangent graph roughly looks something like that. And this one have arrows. These two do not, because we do have a defined domain and we do have a defined range, so they just look exactly like this. All right, so if you need to pause this to take an image or write this down in your notes, please feel free to do that, but I'm going to continue on with an example. So we're going to evaluate the inverse trigonometric function, and the one that we are going to evaluate is y equals sine inverse, so the inverse sine of 1/2. So recall that the range, we just saw the range, recall that the range of the inverse sine function is between -pi/2 and pi/2, or -90 degrees and 90 degrees. So we're looking for the expression of 1/2, which means we're representing, we need to look for the angle that gives us the range of 1/2. All right, so going back to my unit circle, make this look more circle-like. That's pretty close. Move this over here to go back to my unit circle. Get my x's and my y's here. So looking at my unit circle, pi/2, or 1/2 is going to be between here and here. So this is my domain between here and here. And 1/2 as positive sign, that means that we have the positive y, and positive y is in this sector in quadrant 1. And so we're somewhere here. All right, so I'm going to grab a different color. I grab this dark blue. So I know here at this theta, at this point, we're looking at some x and then 1/2. So think about what angle has a sine of 1/2, and can we work backwards in degrees or radians? So now I could say that theta is equal to the inverse function of 1/2, which is going to be 30 degrees. Okay, so if I need it to be radians, I also could say that 30 degrees times, I'm just going to convert this to remind you of the conversion, times pi over 180, and we get pi over 6. So we can therefore say, get that third triangle, sine inverse, or inverse sine, I don't know why I keep saying sine inverse, inverse sine of 1/2 is 30 degrees, or pi over 6 radians. All right. What if I change this up? What if I did tangent? So y equals tangent, the inverse of tangent, of negative root 3. Well, again, if I'm looking at my unit circle, for it to be negative, this would be a positive tangent. This here would be a negative tangent. This quadrant would be a negative tangent. So we have two situations where we have a negative tangent. Now we're looking for a root 3, and we are actually looking on the domain from this point to this point. So we're going to go with quadrant 4. Okay, quadrant 4, we're looking for a root 3. So that means that sine over cosine needs to equal root 3. Well, thinking about it, you have here you have the square root of 1/2, the square root of 3 over 2. The 2's would cancel out, and we're left with 1 over root 3, or root 3 over 3. So it's not going to be the pi over 6. I'm going to go with the pi over 3, which is the reverse of this, which is going to be root 3 over 2, and this is going to be the reference angle of pi over 6, pi over 3. And so what we see here is 1/2. We see this as root 3. So we're in quadrant 4. We're looking at negative root 3 with a reference angle of pi over 3. And if I were to do the terminal angle in this case, I would have to rotate the other way around. And we would find that we are at, well, this is negative pi over 3. Or the other way around is pi over 3 pi over 2, and then we have 5 pi over 3. All right, so there you have it. There is a different example of using tangent. Again, it's thinking about what those unit circle points are, the ones that I've asked for you guys to memorize, and using them to find the angle. All right, so guys, if you have any comments or questions, always feel free to ask, and I will catch you in the next video.